Today we are solving exponential problems where once again our exponent is going to be our variable. So as we're looking at this, our very first goal in order to solve these is we need to make sure that our bases are the same. So as we can see, we have an 8 and a 2. Now whenever you have two that are not the same, you always look at the smaller one, which in this case is 2, and see if you can multiply that number by itself a number of times to get to the other one. So in this case, we do know that 2 times 2 times 2 is 8. Therefore, we can rewrite our 8 as 2 to the third power. Remember, your base is the number that you write down, and your power, your exponent, is the number of times that you multiply by itself. So I'm going to go ahead and take my 8, and I'm going to rewrite it as 2 to the third power. And then whatever my exponent is, I'm going to put that inside of a set of parentheses next to that. And then, of course, I have 2 to the 6th power. Now, you've noticed that at this point, we do have our bases the same. When our bases are the same mathematically, we can go ahead and simply get rid of them and rewrite what is remaining up top. So we have 3 times x, which is 3x, our equal sign, and that's equal to 6. So we've made a problem that was somewhat difficult into something more manageable. Now a one-step equation. We're now going to finish up by doing the opposite of multiplying by 3, which is dividing by 3, and our final answer, x is equal to 2. So what we're saying is 8 squared is equal to 2 to the 6th. So we're going to go ahead and take a look on Desmos and just double check this, and that way we can verify our answer. So we have 8 to the x power, and we think x is 2. So that's going to be 8 squared. And you can see that's 64. And then on the right side, we have 2 to the 6th power, which is also 64. So we know that we were correct, and x is equal to 2. If I plug in x and it does not equal the same as the other side, then I know I've made an error and I need to relook at my work. Okay, let's go ahead and look at B. So in this case, my smaller number is 3, and I know that 3 times 3 is 9, so I can rewrite that as 3 squared. So I'm going to go ahead and write 3 squared, put what my current power is in parentheses, and that's equal to 3 times 2x plus 1. And so once again, I've made those bases the same, so we can have them go away and write what's remaining. 2 times 2 is 4, and that's equal to 2x plus 1. And now we're just going to solve for x. Subtract 1 from both sides, and I have 3 is equal to 2x. Divide both sides by 2, and x is equal to 3 halves, or 1.5. So let's go ahead and check. So we're going to plug once again 1.5 in for x. And we want that to be equivalent to 9 squared. So we have 9 squared, which of course is 9 times 9, which is 81. And then we have 3 to the power, and we put these in parentheses so it stays up there. Parentheses. 2 times 1.5, which is our x value, plus 1. And then we go ahead and close those parentheses. And once again, we're simply replacing our x for 1.5. And as you can see, we have 2 equal answers. And so we know that we are correct. Okay, let's go ahead and take a look at this last one. Now, this one's a little tricky because I have 4 and 32. So if I look at my smaller one, I have 4 times 4, which is 16, times 4 more, which is not 32. So 4 doesn't work. However, when I see this, I notice that 2 is also a number that we can make 4 up to. So we have 2 times 2 is 4. So I can replace that as 2 squared. But if we keep going, times 2 is 8. Times 2 is 16. Times 2 is 32. So I can reach both of them by multiplying by 2's. So 2 squared is 4. So I'm going to put 2 squared and put my 2x in my parentheses, is equal to 2. And let's see how many 2's we multiply to get 32. We have 1, 2, 3, 4, 5. So we know that 2 to the 5th power, 2 times 2 is 4, 8, 16, 32, is 32. And then we put our x plus 5 in parentheses. Okay. Once again, we've gotten our bases the same. And now we have 2 times 2x is 4x is equal to 5 times x plus 5. Then we're going to go ahead and distribute. 4x is equal to 5x plus 25. And I'm going to go ahead and subtract 25 from both sides. And we're going to subtract 4x from both sides. Once again, you can do these one step at a time if you prefer. Get a pen that works here. Minus 4x minus 4x. So we have negative 25 is equal to, and right here our 4x and negative x canceled out. 5x minus 4x is simply x, and our 25 cancels out. So we have x is equal to negative 25. So let's go ahead and check this in Desmos. So once again, we're going to type in each side by itself, and we're replacing the x with negative 25. So let's take a look-see at our Desmos. So our first one, and once again, this is the hardest type that you're going to see this year. We have 4 to the 2 times negative 25. And look at that number. Like, that is a very small number. You can tell because we have a negative power. And our other one is 32 to the negative 25 plus 5. And as you can see, even though it's a very, very, very small number, we can see that indeed they are the same. So we know that our answer is correct. And so we have for our answer today, negative 25 for that third problem. So to recap, as we're solving these types of problems where we have variables as exponents, your goal is to make the bases the same. Once the bases are the same, you can ignore those and simply set the powers equal to each other and then solve for x.